Hello friends, I welcome you all to my channel. In this video, I will solve the DPP sheet number 3, which are problems on limits of the exponential indeterminate form, that is 0 to the power 0, 1 to the power infinity and 0 to the power infinity. So let's get started. Okay, so let's start solving the problems. The first problem is limit x tends to 0, e to the power x plus e to the power minus x minus 2 divided by x square to the power 1 by x square. Now, to check the indeterminate form, we see fx is e to the power x plus e to the power minus x minus 2 divided by x square, and gx is 1 by x square. If you substitute x0 in fx, you will see that it is taking the form 0 by 0. So it is not very apparent uh, that what form this limit is taking. Gx is obviously tending to infinity. So the the three indeterminate forms are 0 to the power 0, 1 to the power infinity, and infinity to the power 0. So we have only one indeterminate form, which is 1 to the power infinity. So quite obviously, or most probably, the fx will tends to 1. But you can always check that since it is taking the form 0 by 0, you can use L'Hopital's rule and check that it is indeed tending to value 1. So we have this as, if we apply L'Hopital, we get e to the power x minus e to the power minus x by twice x. Again, if we apply L'Hopital, we get e to the power x plus e to the power minus x by 2. Now, if you substitute the value, we will get this is 1. So fx is tending to 1. Fx tending to 1, and since x tends to is tending to 0, gx will obviously tends to 1 by 0 tending to infinity. So the form is 1 by infinity form. So to solve, as we have discussed in previous video, we can use the direct formula for solving 1 to the power infinity form. So using direct uh, formula for 1 to the power infinity, so the answer will be e to the power limit x tends to 0 gx fx minus 1. So we have limit x tends to 0, 1 by x square e to the power x plus e to the power minus x minus 2 x square minus minus 1. This becomes e to the power x tends to 0, e to the power x plus e to the power minus x minus 2 minus x square by x to the power 4. Now this is of the form, this limit is of the form 0 by 0. Uh, so we can use now L'Hopital's rule to further solve this limit. After applying L'Hopital rule, we get e to the power 0 x tending to 0 e to the power x minus e to the power minus x minus x minus twice x by 4x cube. It is still of the form 0 by 0 form, and we can further apply L'Hopital rule. And we get e to the power limit x tends to 0 e to the power x plus e to the power minus 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 2 by 4 x square. Again we are having a 0 by 0 form, and we further apply L'Hopital's rule. And we get e to the power x tends to 0 e to the power x minus e to the power minus x by 24x. Now it is again of the form 0 by 0 form, and we further apply L'Hopital rule. And we get e to the power x plus e to the power minus x by 24. Now we can substitute the value of x equals to 0, and we get e to the power 1 plus 1 by 24. This is equals to e to the power 1 by e to the power 1 by 12 is the answer. Okay, let's see the next problem. The next problem says limit x tends to infinity 1 plus 1 by x plus k by x square whole to the power 2x. So over here we have fx equals 1 plus 1 by x plus k by x square, and gx equals to twice x. So x tends to infinity implies fx is tending to is tending to 1 plus 0 plus 0 tending to 1. So fx is tending to 1, and since gx x is tending to infinity, gx will also tends to infinity. So therefore the form is 1 to the power infinity form, and we can directly use the formula. Using direct formula for 1 to the power infinity, we get the answer as e to the power limit x tends to infinity gx fx minus 1. This becomes e to the power x tends to infinity 2x 1 plus 1 by x plus k by x square minus 1 minus 1. This becomes e to the power x tends to infinity 2x x plus k xs square. This becomes e to the power limit x tends to infinity we bring the 2 outside and we get x plus k by x. And so now in the previous video I discussed that for limiting value of a rational function where the numerator and the denominator are polynomials of both having degree n and the coefficient of the highest power of x in both numerator and denominator are a and b, then the limiting value is a by b. So in this example, the coefficient of highest power of x are 1 and 1. So the limiting value of x plus k by x when x tends to infinity becomes e 1 by 1. This equals e square. This is the answer. Let's see the next problem. The next problem says limit x tends to 0 plus x to the power x. Now over here we see fx is x and gx is x to the power x. So fx is obviously tending to 0 as x is tending to 0 plus. Now what is gx tending to? Gx is x to the power x, which is again of the indeterminate form 0 to the power 0. So uh, we have to check what is the limiting value of x to the power x. Uh, so we quickly find the limiting value of since fx is tending to 0 and the indeterminate form with fx tending to 0, there is only one in such indeterminate form, which is 0 to the power 0. So most probably the limiting value of x to the power x will be 0, but still let's check that out. So if we try to find the limiting value of x to the power x, it is of the form 0 to the power of the indeterminate form 0 to the power 0. So applying uh, applying the general method for solving exponential indeterminate form, uh, let's say y. Okay, so in the previous video I have discussed that the general form for solving exponential indeterminate form, uh, like the formula was x tending to a fx to the power gx equals e to the power limiting limit of gx log of fx. This was the general formula for solving exponential limits. Now over here, fx is x and fx is x and gx is x. We are trying to solve we are trying to find the limiting value of gx. So therefore, limiting value when x tends to 0 positive, x to the power x equals e to the power limiting value of x tends to 0 positive x log of x, that is x. Now x log x is 0 and log x, when x tending to 0 positive, log x is tending to minus infinity. So x log x is of the form 0 into infinity. 0 into infinity form. We can uh, 0 into infinity form. So we can solve this by transforming it to either 0 by 0 form or infinity by infinity form. So this is equals limit x tending to 0 positive log x by 1 by x. This becomes infinity by infinity. Applying L'Hopital rule, we get 1 by x minus 1 by x square. This equals limit 0 positive minus x. So limiting value of minus x at x tends to tending to 0 positive is 0. So this is 0, this is 1. So we see that gx is tending to uh, uh, let me check if I'm right or wrong. 1 by x fully by infinity is infinity, and log x is 1 by x and minus x square minus x, yes, 0. Minus 0 is 1. Okay, so uh, minus, yeah, okay, so gx is tending to 1, so it is having the form fx is tending to 0, 0 to the power 1. It is not falling in the category of the standard indeterminate form, uh, 0 to the power 0 or 1 to the power infinity or infinity to the power 0. At least we have find out that gx is tending to 1. So let's try the general method of solving exponential limits. Let by equals to x to the power x. Therefore, log of limiting value 0 plus y equals to limit of 0 plus log y. This is limit 0 positive log y uh, log uh, log y x to the power x. This is 0 positive x to the power x and log x. So at to solve this, we know that limiting value of x to the power x when x tends to 0 positive is 1, and the limiting value of log x at x tends to 0 positive is minus infinity. So this equals 1 because limiting value of x to the power x we just we just calculated to be 1, and log of x at x tends to 0 positive is minus infinity. Uh, mm, this is coming to be minus infinity. And so we we got log of limit x tends to 0 positive y equals to minus infinity. This implies limit x tending to 0 plus y equals e to the power minus infinity, which is 0. So 0 is the answer. Okay, so let's see the next problem. It says limit x tends to infinity e by 1 minus 1 by e minus x by 1 plus x all to the power x. Now we slightly modify the second term here, 1 by e minus x by 1 plus x. We slightly modify it, uh, and we will see if we modify this expression as 1 plus uh, 1 minus hmm, uh, uh, we can rewrite this term as 1 by e minus 1 plus 1 plus x minus 1 divided by 1 plus x. This becomes 1 by e minus 1 plus 1 by, okay, 1 by 1 plus x. This equals 1 minus e by e plus 1 plus x. So we also see the similar term, e is a constant. So over here we have e by 1 minus e, and in the second term, we got 1 minus e by e. So let's uh, say this constant, let's say this constant e by 1 minus e as k. It will be easier to uh, it will be less lengthy to solve this problem if we just let e by 1 minus e as a constant k. So now fx becomes, fx is k, k multiplied by 1 by k plus 1 by 1 plus x, and gx is x. So x tending to infinity implies fx tending to 1 by k plus 0 tending to 1. So clearly uh, fx is tending to 1 and gx is tending to infinity as x tends to infinity. So therefore we are having 1 by infinity form. So now we directly apply the formula for 1 to the power infinity using direct formula for 1 to the power infinity. We have the result e to the power limit x tends to infinity gx multiplied by fx minus 1, which in this problem becomes x tending to infinity, gx is x, and fx minus 1. What is fx? Fx is uh, fx becomes, fx is k into 1 by k plus 1 by 1 plus x. If we bring the k inside, it will be 1 plus k into 1 by 1 plus x. So fx minus 1 becomes 1 plus k into 1 this minus 1. This becomes x tends to infinity x 1 plus uh, k 1 plus x. Hmm. So this becomes limit, we bring the k outside since k is a constant, limit x tends to infinity x by 1 plus x. And as we have already discussed in previous video that the limiting value of a rational function like this, where the numerator and the denominator are both polynomials of the same degree, and the highest and the coefficient of the highest uh, power of x in both the numerator and the denominator here is 1. So the limiting value of x by 1 plus x when x tends to infinity is 1 by 1. So this equals k equals k to the e to the power k, and k over here we have, so k is e to the power 1 minus e. This is the answer. Okay, let's see the next problem. Next problem says limit x tends to infinity a1 1 by x plus a2 1 by x like this plus an 1 by x divided by n whole to the power nx. So first we have to identify the indeterminate form. Clearly the gx over here is nx and it tends to infinity. So most probably the fx will tend to 1. Just to check that out, to be clear about that, we see that all the terms in the numerator of the fx, that is ai 1 by x, is tending to ai 0, because 1 x tending to infinity, that means 1 by x tending to 0. So this tending to 1. So fx is tending to 1 plus all the terms will become 1, 1 plus 1 pi n, and we have n terms over here. This tending to n by n tending to 1. So fx is tending to 1, and gx is nx, implies gx is tending to infinity. So clearly the form is 1 to the power infinity. So we directly apply the formula for the 1 to the power infinity form using direct formula of 1 to the power infinity. We get the answer as e to the power limit x to the x tending to infinity gx fx minus 1. This becomes, in this problem, limits x tending to infinity, gx is nx, and fx is a1 a2 like this, an by n minus 1. Okay, so this becomes e to the power x tending to infinity n nx. What's the problem? Nx. Fx minus 1 is n. N cancels out. Minus 1 by x. We see all a to the power x, and we have a standard limiting result a to the limit x tends to 0 a to the power x minus 1 by x is 0. Mm, but over here we have 1 by x, it is not x, even though 1 by x is tending to 0. Uh, what if we just substitute 1 by x by t? Let t okay, let's put let t equals to 1 by x. This implies t tends to 0 as x tends to infinity. Now if we substitute uh, x by with t, we get limit t tending to 0. Over here we get n by t and a1 to the power t plus a2 t plus an t by n minus 1. This becomes limit t tending to 0. The n will cancel out. So here we will have 1 by t, and over here we will have t a2 t plus a n t minus n minus n. The n gets cancelled out. Okay, so there is minus n. We can distribute, we can take minus 1, we can write minus n as minus 1 minus 1 minus 1 n times of minus 1 and merge uh, uh, each each of those minus 1 with the a to the power t terms, and we will get a form a to the power t minus 1, and in the denominator we already have t, so we can then apply the standard result limiting limit of x a to the power x minus 1 by x limit when x tends to 0 is log a. So let's see, e to the power limit uh, we have this after simplification. uh, okay, now we we have the standard form. We can apply limits to the individual standard form and see that it becomes a to the power limit so we apply the standard result a to the power x minus 1 by x when x tends to 0 is log a. So we get log of a1 plus log of a2 plus log of an. If we merge all the log terms by using the formula log ab equals log a plus log b, we get this becomes all these log have base e, so this becomes a1, a2, a3, an. This is the answer. Okay, let's see the next problem. The next problem says limit x tends to 0, 1 plus tan x by 1 plus sin x whole to the power cosec x. So fx here is 1 plus tan x by 1 plus sin x, and gx is cosec x. So when x tends to 0 implies fx is tending to 1 plus tan 0 by 1 plus sin 0. This is tending to 1 by 1 tending to 1. So fx is tending to 1, and gx is tending to 1 by sin 0 tending to 1 by 0 tending to infinity. Therefore, the form is 1 to the power infinity form. Now we will directly apply the formula for 1 to the power infinity. Using direct formula of the result will be e to the power limit x tends to 0 gx fx minus 1. This becomes limit x tends to 0 1 by sin x and 1 plus tan x 1 plus sin x minus 1. This becomes limit x tends to 0 1 by sin x tan x minus sin x by 1 plus sin 1 plus sin x. This becomes limit x tends to 0. We bring out sin x common from the numerator of the second term. Uh, and we get 1 by cos x minus 1 divided by 1 plus we have taken sin x from common from the numerator of the second term. So this sin x cancels out, and we get uh, 1 minus cos x 1 plus sin x. There is a standard result limiting value of 1 minus cos x whole divided by x when x tends to 0 is 0. If we use that result, like if we create the x, adjust the x, and we are left with cos x 1 plus sin x. So cos x 0 is 1, 1 plus sin x at x tending to 0 is 1. So the result becomes 0, 0, 1 by which is 0, which is 1. So 1 is the answer. Let's see the next problem. It says limit x tends to 0 cos x plus a sin bx whole to the power 1 by x. So fx is cos x plus a sin bx, and gx is 1 by x. When x tending to 0 implies fx tending to cos 0 plus a sin 0 tending to 1 plus 0. So fx is tending to 1, and obviously gx tending to gx is tending to 1 by 0 tending to infinity. So the form is 1 to the power in infinity form. We can directly use the direct formula of 1 to the power infinity using direct formula of 1 to the power infinity. We get the answer as e to the power limit x tends to 0 gx fx minus 1. This becomes limit x tends to 0 1 by x cos x plus a sin bx minus 1. So this limit is now of the form 0 by 0 form, and we can apply L'Hopital rule, and we get e to the power limit x tends to 0 minus sin x plus ab cos bx by 1. Now, if we substitute the value of x in the limiting function, we get e to the power minus 0 plus ab1 is equals e to the power ab is the answer. Okay, let's see next problem. It says limit x tends to 0 plus 1 plus tan square root x whole to the power 1 by twice x. So fx is 1 plus tan square root x. Since x is tending to 0 positive, root x is will also tends to 0 positive. X tending to 0 positive implies root x tending to 0 positive implies tan x root x 0 positive. 0 positive. This implies uh, tan square x also tending to 0. This implies 1 plus tan square x tending to 1. Therefore, fx tending to 1 and gx will tend to 1 by 0 tending to infinity. Therefore, the form is 1 to the power infinity form, and we can now directly apply the direct formula for the 1 to the power infinity form using direct formula of 1 to the power infinity. We get the result as limit x tends to 0 positive gx fx minus 1. This is 1 by 2x tan square tan square x. Hmm. Hmm. 1 by 2x and fx minus 1 is tan square root x. So we can see the result. We can apply the result tan x by x limit at x tends to 0 is 1. This equals 0 positive. Since it's the right hand limit at 0 positive, uh, we can use it like this. We know that the right hand limit of fx at a equals limit h tends to 0, where 0 is a positive value, f of a plus h. So over here we can apply this. In this example, and we get limit h tends to 0, 1 by 2, 0 plus h tan square 0 plus h. This equals limit h tends to 0, tan square root h by twice of h. And this is limit h tends to 0, tan of h root h square, and we are left with the half. So this is root e is the answer. Limiting value of we have here tan root h divided by root h, and h tends to 0, which is 1, because we have the same uh, root over h in tan as well as in the denominator. So we have used the result limit x tends to 0, tan x by x equals 1. Okay, let's see the next problem. Limit x tends to 0 positive x to the power 1 by log e sin x. So we have fx equals 0, sorry, fx equals x, gx equals 1 by log e sin of x. So x tending to 0 positive implies fx tending to 0. This also implies sin x tending to 0 implies log of e sin x tending to log of e is 0 tending to minus infinity. This implies 1 by log e sin x tending to 1 by minus infinity tending to 0. So here the form is 0, 0 to the power 0 form. So we have to proceed with the general method for solving exponential indeterminate limit. So we let y equals to x to the power 1 by log e sin x implies log of limit x tends to 0 positive y equals to limit 0 positive y. This equals uh, x to the power log e sin x this equals plus the power 1 by log e sin x comes to the front, and we get log e x by log e sin x. This is of the form log e x when x tends to 0 tends to minus infinity, and similarly log e sin x also tends to minus infinity when x tends to 0. So here we have infinity by infinity form, and we can apply L'Hopital rule. And we get uh, 1 by x cos x by sin x. This equals limit x tends to 0 positive 1 by x cot x equals limit x tends to 0 positive tan x by x, which is 1. We know by the standard result. So we got log e limit x tends to 0 positive y as 1. This implies limit x tends to 0 positive y as e. E is the answer. Okay, that was the solution for the DPP sheet number 3. I have prepared another set of problems of this exponential indeterminate form. I will attach the link to the PDF in the description below, and you will please try to solve them, and I will provide the solution to the DPP sheet number 4 in the next 24 hours. Thanks for watching, and as usual, if you find this video useful and beneficial, then please support me by subscribing to my channel and like the video, and share my channel and my videos with your friends, and also do not forget to press the bell icon so that you will be notified by my future videos. Okay friends, until the next video, take care and bye.